This is 3-6, but part 2. So remember the second part, we're going to use function notation to evaluate functions, and then we're going to identify domains and ranges of those functions. So let's skip where we left off on function notation. Okay, so we have this new notation, and it looks like f parentheses x. Okay, we pronounce this f of x. F is just telling us the name of the function. Right? We could have g of x, we could have h of x. So this is function g, this is function h. It's just a name. X is going to be the domain. Remember, that's the inputs. And f of x as a whole thing, f of x is going to be the range or the output. Okay, so this serves as a y. It's just a fancy y. Okay, because look at this function g. It says g of x equals 3x minus 4. Well, that's basically the same as y equals 3x minus 4. Now we just know that it's a function. Okay, when we have it as y equals, we don't know yet if it's a function. But when it's in this form, if the book or the web assign gives it in this form, we know it's a function. We know that each input is only going to have one output. Okay, so evaluate this function. Okay, so example A says g of 1. Okay, so 1 is the input. It's in the x's position, right? It's not g of x, now it's g of 1, which means we're inputting 1 into this function where we see an x. Okay, so g of 1, that's like our y value. We're trying to figure out what g of 1 equals. Well, I have 3 times x, so I'm plugging in 1 and then minus 4. And then I just simplify this, so I'd get negative 1. So g of 1 equals negative 1 here. Okay, I'd get something different if it was g of negative 2, wouldn't I? So let's do g of negative 2. Now instead of 3 times 1, it's 3 times negative 2, and then subtract 4. Make sure you're following order of operations, so multiply and then subtract. And you'd get negative 10 here. Okay, what about this one, part C? It says g of y. So now what is it saying to do? It's saying, hey, y, I need you to input it wherever you see an x. So instead of plugging in a number, I'm plugging in y and simplifying. So 3 times y is just 3y, and then minus 4, there's nothing I can do there. I can't subtract those aren't like terms. So my final answer is 3y minus 4. Same thing here, except now it's a quantity, right? I'm not just plugging in x, I'm not just plugging in 1. I'm plugging in x plus 1 in for x's spot there. So it says 3 times x. Well, I'm putting x plus 1 in its place, and then I'm simplifying. So how do I get rid of these parentheses? Well, I'm going to distribute. So 3 times x is 3x. 3 times 1 is 3. And then drop down your minus 4. I can simplify. These are like terms. So a positive 3 and a negative 4 make negative 1. So 3x minus 1 is as far as I can go. Now this one is saying, hey, find g of x and add it with g of 1. Okay, so that's two different things, and then we're adding them together. It's two different functions. So g of x plus g of 1. Let's figure out what that equals. Well, it's saying first plug in x. Okay. Plug in x to that function. Then you go ahead and write your addition sign. Right? This stood for g of x. And we're adding it with g of 1. So plug in 1 into x's spot, and simplify. So let's work with g of x. Let's simplify it down to 3x minus 4. And if I were to simplify g of 1, I'd get a negative 1. Can I simplify this any further? Well, sure. I have a like term here of negative 4 and plus a negative 1. When I combine them, I get a negative 5. So 3x minus 5 is g of x plus g of 1. I want you to notice the difference. Over here, I had g of x plus 1. X plus 1 was in the parentheses, and I got 3x minus 1 for my answer. Look over here, I had g of x plus g of 1. Those are two separate things, right? So x plus 1 in parentheses is different than x and then plus 1. Okay, let's go on to evaluating a piecewise function. So we were evaluating functions in general. This function g was just a normal function, but we now have what's called a piecewise function. So it's saying that f of x it has two different categories basically. So I have x squared plus 1 if your domain, what you're plugging in is a number less than 0. But if you're plugging in a number that's greater than or equal to 0, then you're using the x minus 2. So let's try one out. Let's find or evaluate f of negative 1. So negative 1 is what we're plugging in. Which category does that meet? Is it a number less than 0 or is it a number greater than or equal to 0? And that is less than 0. So we're going to be using this top function, because the if part in your piecewise function tells you which one to use. Use the top or use the bottom. This one satisfied the top. Okay, so we're using the top, which means I'm plugging in negative 1 wherever I see an x. So f of negative 1 would mean negative 1 squared plus 1. Squaring negative 1 gives you a positive 1. So your final answer here would be 2. Let's go over here though. F of 0, which category would this meet? Well, 0 isn't less than 0, but it is equal to. So it would satisfy the greater than or equal to. So this time we're going to use the bottom function. So I'm plugging in 0 for x, and here it says x minus 2. So 0 minus 2 for my final answer of negative 2. Okay, so in a piecewise function, you're not doing anything different. You just have to decide whether or not you're using the top or bottom. And the if statement will tell you which one to use. Okay, remember that domain is a set of inputs, okay, and range is a set of outputs. Domains can have some restrictions, right? We can't always just plug in any number for x. Sometimes there's cases where we aren't able to plug in a certain x. So for instance, look at part A. It says f of x equals 1 over x minus 3. Now something to be careful about when you're finding domain is fractions, because what sort of fractions can we not work with? What sort of fractions give us undefined when we type it into our calculator? And those are the fractions where we have a number divided by 0, right? It's no good to have 0 in the denominator. 7 divided by 0, that's going to spit out error in your calculator. Okay, so we don't want 0 in the denominator. So other than that, I can plug in anything for x, right? I could plug in negative 19 and I'd get a fraction. I could plug in 17 and I'd still get a fraction. But I can't plug in a number for x that would make this denominator 0, right? So my domain here, it's a set, okay? It's a set of all real numbers. So we use this capital R with two legs here. It's a set of all real numbers, except for when this denominator is 0. So what number for x can't this be? Well, when is x minus 3 equal to 0? When is this bottom number 0? So that's an equation I need to solve. So if I add 3, I get x is equal to 3. When x is 3, my denominator is 0, and that's not good. So I want any number except when x is 3. Okay, another way to write the domain is instead of using the word except, we can write all real numbers, but x cannot equal 3. Okay, so all real numbers, x cannot equal 3 though. Okay, so that's for fractions, that's for denominators. What about when we have square roots? Is there any number that we don't like underneath a square root? Well, can we take the square root of 0? Sure, it's 0. Can we take the square root of positive numbers? Yeah. Can we take the square root of negative numbers? No, we cannot. Right, so like the square root of -1 in your calculator, that would pop out as error. Okay, so we don't want any negatives underneath our radical. So our domain here is going to be all x's, or all real numbers, all numbers except for when? What numbers will be negative? Well, when I have x's that are less than 0, those numbers are negative. Okay, so another way to write this, again, is all reals. X cannot be less than 0. Okay, any numbers less than 0 make this negative, right? If I plug in -5, if I plug in -0.001, those are both numbers less than 0, and that's not part of our domain. Okay, let's look at part C. F of x equals the absolute value of x minus 4. Are there any numbers that we can't plug in for x? So we want to think about 0, we want to think about positive numbers, we want to think about negatives. Can I take the absolute value of 0? Yeah, I get 0. Can I take the absolute value of a positive number? Sure. Can I take the absolute value of a negative number? Yeah, it just turns positive. So anything will work here. Those are all fine. There is no exception here. So my domain is the set of all real numbers, anything for x. Doesn't matter if x is smaller than 0. Doesn't matter if x is greater than 0. Doesn't matter if x is 0. I'm going to get out an answer when I plug in anything for x. Nothing in my calculator is going to say error. Okay, part D. F of x equals x squared plus x minus 2. Is there anything that I can't plug in for x? I can plug in negative numbers. I can plug in 0. I can plug in positive numbers. Nothing is restricted here. I don't have a square root and I don't have a denominator. So because I can plug in anything, my domain again is all real numbers. Okay, so just like part C, same thing for part D. I can plug in anything. Okay, part F, A, B, C, D, E. Actually, let's jump to E. E becomes before F. Not good with alphabet, just good with numbers. F of x equals the square root of x plus 4. So again, I see a square root, and what can we not have under our radical? Well, we cannot have a negative. In our radical, in our square root. Okay, so we can't have any numbers under here that are less than 0. So let's set up something that says, let's set up an inequality that says this under my radical, x plus 4, needs to be greater than or equal to 0. Okay. It needs to be greater than or equal to 0. If it was less than 0, then those would be negative values. Okay, so how do I solve for this? Well, I'm going to subtract 4. And I get x is greater than or equal to negative 4. Okay, so any number that's greater than or equal to 4, I can plug in. That's my domain. Okay, it's all real numbers as long as x is greater than or equal to 4. Okay, which means it's all reals except for those x's that are less than negative 4. Either one of these would work, right? All reals, x cannot be less than negative 4. I'd probably prefer this one over this one, but they're saying the same thing. It's saying x needs to be greater than negative 4, which means it can't be less than negative 4. So same thing up here in this radical. X couldn't be less than 0, so how else do I say that? Well, I could say x needs to be greater than or equal to 0. Okay, so numbers bigger than 0, which means it can't be numbers less than 0 for your domain on both of these. Okay, if you have trouble typing that into WebAssign, just call me over. If you can tell me in your own words what the domain is, I'd be happy to type that in for you. So the last one, part F, the domain here. Well, I see a fraction, so I'm thinking, okay, well, this bottom part can't be 0. So let's figure out what numbers make this bottom part equal to 0. So if I figure out what numbers make it equal to 0, then I know I don't want those in my domain, right? Because I cannot have 0 in the denominator. Okay, so this equation, I put this example in your notes because I think it's important to see. This is two things being multiplied, right? T is being multiplied by t plus 2. Well, when I multiply two numbers and they equal 0, that means one of these has to be 0, right? Either it's the t is 0, or it's the t plus 2 is 0. Okay? Because that's called the zero product property. If two numbers or two quantities are being multiplied and they equal 0, shoot, one of them had to be 0 itself. Okay, so either t is 0 or t plus 2 is 0. All right, either this one's 0 or this one. Okay, so t is 0. That's solved for t. Let's solve this one for t by subtracting 2. Okay, so these are the two values that make my denominator 0. 0, if I plugged in 0 for t, I'd get 0 in my denominator. If I plugged in negative 2 for t, I'd get 0 in my denominator. That's what I do not want. Okay, so let's write that into our domain. Domain, we could have any number except we can't have, sorry, I wrote x, we can't have t equals 0 or t equal to negative 2. Okay, so another way to write that is all reals, t not equal to 0 or negative 2.